Okay, so the next part is the electromagnetic spectrum. I copied the electromagnetic spectrum out of the book. Radio waves have the longest wavelength. They have the least amount of energy. They're on the left-hand side of the spectrum. And as you go across, the wavelengths get shorter, which means the frequency gets higher, which means the radiation gets more and more powerful. So radio waves have the least amount of energy. Then it goes microwaves, which actually are radio waves, infrared, and then look, then you have the visible part. This is the part of the spectrum people can see, but I want you to notice something. It goes from infrared to the first color of the visible spectrum, which is what? Red. Goes from infrared to red. And then it goes through all the colors of the rainbow. The last color is what? And then what's the next part of the spectrum? Ultraviolet. Okay, so red, orange, yellow, green, blue, indigo, which they say isn't really part of the rainbow anymore, and then violet. And then the next part of the spectrum is ultraviolet, then X-rays, and then the most powerful are gamma rays. Guys, gamma rays are the form of radiation you guys were writing about in your essays. Gamma rays are the rays, and we do receive some gamma radiation from space. So remember, the sun is a nuclear reactor. All right, but we have the magnetosphere, which protects us from that gamma radiation. All right, and so this is the electromagnetic spectrum in order from lowest frequency to highest frequency. And visible light, the only part that we can see, is part of it. Infrared is felt as heat. In fact, we use infrared technology. Those police helicopters, they know, for example, when they have their suspect, they can use infrared technology to detect like their body temperature, right? And then what they'll do is they'll continue flying around, making the person think they don't know where they are. So they'll stay in that spot while they dispatch and get people down below to go get them. So they'll make you think that, oh, they can't find me. There's spotlights everywhere looking for me. I'm going to sit here in this bush. But all along, they have their infrared technology. They know you're there, but they want you to stay there. So they make you think they don't know you're there. And then they go get you. Okay. So, back to light. I copied this part down from the book where I think it's interesting that all the colors combined, red, orange, yellow, all the colors combined in the rainbow produce what? White light. Okay? White light is what we typically see when you turn on the lights or you're outside. That's white light. We use prisms to bend the light, which separates the light into the different frequencies like a rainbow. So here's the order again. Red, orange, yellow, green, blue, indigo from our book, and violet. Longest wavelengths to shortest wavelengths. And white light is when all the colors of light are combined. Okay, properties of light. Light spreads out in all directions from its source. When you turn on a flashlight, the light goes all around. Okay? The light travels in straight lines called rays. This is why we can use umbrellas in the sun for shade, because the light doesn't creep up under the umbrella and go into your face. Okay? It blocks the light. All right? Light travels at the speed of light. This is amazing. 186,282 miles in 1 second. I think it beats sound, don't you? Yeah. Light can travel in a vacuum, and I wrote in parentheses empty space in case you don't know what a vacuum is, as well as through matter. All right, give me an example of something light can travel through. Glass, water, air. Okay. Light at a surface. Three things can happen when light hits a surface. It can be reflected, it can pass through, or it can be absorbed. Reflection, I think we're all familiar with reflection. When light bounces off of a surface, there's a law. The law is that the light is reflected at the same angle at which it hits a surface. Guys, this is just like you bouncing a ball back and forth with a friend. If you guys are both facing a wall and you throw the ball at the wall and the ball bounces off and goes to your friend, you use the law of reflection. You use the law of reflection when you play pool, and you use the wall to guide like where you want the ball to go. That's the law of reflection, and it happens with light too. And when light reflects off of smooth surfaces like glass, you can get a clear image. This is called specular reflection. When light hits a jagged surface like a brick wall, look at what happens to the reflected rays. Okay, is that going to produce a clear image? No, that's called diffuse reflection. Okay? All right. So I will stop here. You guys can put your papers away.